Alright, hello, I'm back. I haven't done anything, but that's okay. I was in Warley for a couple days, and today I'm gonna do stuff. I think the goal is to do some more every day. What was I doing before? I don't remember. I finished this page almost. I guess I'll try to finish up to page 2 today. It's only 7:30. I'm planning to sleep at like 11 today, I guess, or 12. Honestly, whenever I feel tired, but we'll just keep going. Alright, remove elements. Time to keep on going. I was trying to think of, why am I even doing this? What? Huh? They moved the buttons up here. Oh, they're really changing it up. Alright. Oh, wait. The shortcuts are control apostrophe? Oh, okay. Remove elements. I remember doing this yesterday. Or not yesterday, like three days ago. And it not working. So yeah, we'll keep going. It does not equal 0.2. Equal to 0.2. Let's try to get this done really quick. This node iterator equal head. Okay, while iterator next does not equal 0.2. We'll have. So I think before I need a previous. Prev iterator equal, sure. So now I have one ahead and one previous. So now I can just check this value against the previous. I think that's the strat that I'm supposed to go for. So while iterator at val does not equal val, it's equal to val. So if it is equal to val, so if this was like 1, 1, 6, 3, 4, 5, 6, for example, so these are equal and val is 1, then I need to remove this one. So prev at list node delete node, that should be consistent, is equal to iterator. So I'm deleting iterator. Iterator is iterator is equal to iterator at next. Delete node. Delete node equal null pointer. So we don't have a floating one. So pretty much I make this. So iterator is here. Prev is here. I make this iterator next. And I make prev iterator next equal to iterator. And then, so that pretty much deletes this, and then this is still the previous iterator. Yeah, so that works, I think, for most cases. And then we just need to, at the end, do prev iterator equal prev iterator at next, and iterator is equal to iterator next. And I think that should work. This should stop while iterator is not equal to null pointer. So while iterator val, I think I can change this to if and also check iterator next null pointer, and then if that happens, then we can do this. If not, then don't do that. Actually, I think I always want to iterate. Unless... Yeah, okay. Let's see if this case works. So we have 1, 2, 3, 6, 3, 4. So head... We got iterator ahead, so 1, 2, 6, whatever, we don't really use that. Prev iterator at 1, 2, okay. And then, like, of course, all the numbers are there. So... Is it equal to val? No. So we continue on prev iterator. So is 6 equal to val? Yes, it is. 6 is equal to val. Sorry, I think this is iterator. Iterator, prev iterator. So is 6 equal to val? Oh, let's just remove elements in general. So I need to remove the first one too, if it's equal to val. I think we can deal with that case. So we can say while iterator dot val is equal to val, so this is the head, then we can do you can do list node delete node is that head, and then we can do head is equal to head at next. So this will get rid of all the first ones, because it needs to point, head needs to point to something, so it needs to point to whatever, and head does not equal no pointer. Okay. So iterate does not equal no pointer. So this is a special case. There we are. Anyways, 6. So iterator val is equal to val. So 6 is equal to the val. Delete node is equal to iterator. Iterator is equal to iterator next. So it's 3. Delete the node. Prevs next is equal to iterator. So that's right here. And then we iterate past 1. But that doesn't work if this is 6. I think I put an else here, so that doesn't happen. So let's say we have a 6 here, that won't happen. And then it'll come back here. Is iterator val equal val? Yes, it is. Deletes this. Iterator next is equal next. Prev next is equal to iterator. Boom. Now let's say it's not equal to val, so it's 4. Then we can iterate normally. Iterate normally. Is iterator val equal to val? Yes, it is. This is deleted. Iterator is next is null pointer. Previous iterator next is iterator, so it's just equal to null. That doesn't happen. We're at the end. Okay, so we can do an else. I think that works. Do I have to return something? Yes, return head. The pointer keeps track. It'll keep updating. Control apostrophe, I think. Okay, thank you. Member access within null pointer of type solution at line 25. While head does not equal. That should deal with that value. 27 if iterator val. Iterator should equal null pointer here, so that shouldn't work. Because this will go. Val. Head 7, head 7, head 7, head 7. Should give 7 every single time. It's equal to, this is equal to the previous head though, so that's why this should just go here. Okay. because it doesn't keep track of the head. We have to manually update it. Okay. If I guess I no. There is equal to next. Actually, I guess I can just do this. If head is equal null pointer, return null pointer. And then this, I can just leave as one line. Okay, let's see. Money? Yay! I think I got every case. Nice! We did it. Okay. Cool, so this is... I really want to combine this with this, but I'm not sure how to. I'll make a note of that, though. 203. Okay, I should put like a timer. I want to see how long one of these takes. Let's do a timer. Stopwatch. Okay, 3, 2, 1, go. Given two strings S&T, determine if the X is... What does that mean? If the characters in S can be replaced to get T. All occur... Replace order. Huh. That's interesting. Okay, so I think the strat is to make a map, an ordered map for I mean, I can just do car. So E, for example, will map to A. And then if the key already exists and it doesn't match that rule, then it fails. Keys. Yes, I think that's how to do it. For in I equals 0. Now we can do if S is equal to empty or T equal to empty dot length. What is empty? I think it's empty is a real one. Then we will return false. Are they? Is that false? That may be true. Okay. Okay, never mind. It'll be fine. We don't need that. I is less than S the length. It's the same, so it's fine. I plus plus. And we can do unordered map. How to add to unordered map. I think it's insert. Insert. How do I use insert? Insert. Make pair county insert copy insertion. I'm guessing I can just do comma comma. Okay. Keys insert S at I, T at I, and if the key is already here, I think it's equal to 0. What does this return? Iterator bool inserts new return. Pair whose first iterator bool value successfully inserted. I think 0 successfully inserted. So dot second is equal to 0. So if it's successfully inserted, if not, that if it's successfully inserted, we don't have to do anything, right? Because E maps to A, that's perfect. But if it already contains it, then we have to look at keys at, well, we're mapping S to T, right? So we have to look at S at keys. We have to see if S at I, so the key E for keys at this, so at E, is equal to T at I. So for example, this is E and A, so we're going to insert the key E and A, and we say, hey, we found E again. Does E, what's the value of E? So if it's still A, then that's good. If it's not A, sorry, we got return false. Otherwise, we return true. Alright, let's see. I think that's it. Okay, I don't know how to insert good. Keys.insert unordered map. STC unordered map. Car. Keys.insert. My shopping. Do I have to make an STD pair? I don't think so. Maybe I have to make pair. Insert. Okay, I can just do sorry, I think it's this. Can I get this in? So that makes it into a pair. Do I have to do make pair? Okay. It's still false. Why is that false? So this is insert successfully. So this should type this twice. If it doesn't, then I did it wrong. Okay. This should type twice now. Insert successfully. Okay. So the first one would be, well, I'm confused now. Insert how to tell if success plus. So, yeah, okay, but does it? What does it return? Whether, I'm guessing insert successful, true or false? Insert successful is true. So I want to see if the insert fails. True. Else the insert fails. G and D. Yeah, because this should insert, then it fails. So G and D. If keys at SI, if keys at G, so G does not equal, does not equal TI. That should, why does it not work? I feel like that should. Does not equal, that should be, oh, I returned the wrong thing at the end. Man, okay, there we go. I'm confident that this is gonna work first try. Did not work first try. B and B. Okay, B and B. A and A. D to B. Output true, expected false. Why? B maps to B. A maps to A. D can map to B. What? That should be true, actually. No two characters may map to the same character. A character may map to itself. I did not read that. Okay, so this is B and B, A to A, which is fine. But D to B, we already have D inserted though. B to D to B. B to B, A to A, D to B, no, C to A, no. Can make another set. Alright, mapped. Map dot insert T at I and map set contains map dot contains does not contain TI. Oh, actually I should just do an else if no, because it's gonna insert and map dot contain does not contains TI. Wait, I'll just do this. If TI, then return false. B to B, A to A, D to B will be successfully inserted. Okay, actually, yeah, that doesn't work. So it has to... This has to be false. So... Or sorry, this has to be true. True, so D can insert into B. Man, okay. E can be into A, G can go to D. That's fine. And then G and D, we go here, else are they not equal? We just need something that's like, hey, you can't map to the same key. So if B maps to B, that's fine. If A maps to A, that's fine. I think I need an unordered map. So if T inserts... Actually, no, I don't need that. Okay. I think I'm really close, so just need to think about it a little bit more. So if keys.insert B to A, There could be no duplicates for keys. Oh, I moved that back. So. There can be no duplicates for keys. So D insert B would technically work. The values, though, there can be obviously more than one, because what if there's B, 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 A, that all works, right? So I think the only way I can get this to work is I can insert this in reverse. Like this. TI, so B maps to B, A maps to A, but B also maps to D. So if I insert D maps to B, I have to make sure B maps to the original. So that would be and mapped at the key of TI does not equal, no, is also equal to SI. So mapped at TI, B does not is equal to if not, that's false. Okay, I think that should work. TI, SI. If they're not mapped together, then it's wrong. No, what? Okay, let's do it for this. So mapped keys.insert F to B, that's fine. Mapped T of I is equal to S of I, but T of I of S I doesn't. I think I should just do this no matter what. So we can like at 4. So B maps to B. Okay, A. Here we have mapped at B, which is D, is equal to S of I. Sorry, mapped of B right now is already B. It's equal to S. That's false. False. Run. This should work. What? How? F is mapped to B. It's fine. And then O is mapped to A. Okay, can I write this out? A to B to B, A to A. We also have B to B and A to A. Then we try insert D to B. This will work because there's a unique key, so that would work. But, so this is true, whatever, it's inserted. But mapped at T, I, so right now TI is B, so mapped at B has to be equal to S of I. So S of I right now is just equal to D. So B obviously does not equal to D, so this is false. Since this is false, this else statement works. This is going to be true still, or this is going to be false, so it's fine. Keys at S of I. So keys at D does not equal TI. It's false still. And mapped at T of I does not equal S of I. Not equal to S of I. I think, and this exists. Is that, do you take that? No. No. Count. No, it doesn't exist yet. That's the thing. This record doesn't exist. We just have this. Mapped at T of I, so mapped at B. Does not equal S of I. Does not equal. How is that still playing true? S of I is B, T of I is B, A, D, and B. Okay. So at B, mapped at B of T of I, mapped at B does not equal mapped at B is D. B is D does not equal keys at S of I. Does not equal keys of S of I, not just S of I. This needs to go other. Mapped at T of I, so this should all be in already. Mapped at D does not. Bro, I swear I'm making it like 10 times harder than it has to be. don't I just do another statement? Else if keys at s of I dot find keys at I, so the value of that I need to do this first. So s of I keys at t of I dot find equal keys dot end return false. So if at, so for example here at b of b, that won't happen, but here at d, so find at this at b, if keys at b already exist, return false. Okay, I think this should finally work. What? Oh, I have to do it on the actual map. Keys of bro, I can't solve it. I'm coming back to this. I'm coming back to this later. Bro, it's like right there. Two ands. I need to check keys at insert s of I, t of I. I need to check this is true. I need to check if Sorry, it's gonna be false. Not contains. Okay, so if it contains this B, dot find keys dot okay. If this doesn't work, I'm actually GGing. Oh, I think I did it. Why is it outputting false? B to F, A to O, R to O. That should return false. Okay. B to F, insert into it. Okay, cool. Dot second. Successfully inserted. We move on. A to O. That's also successfully inserted. We move on. R to O. That also successfully inserts. Do I need this in it? Keys of S of I R does not equal. I don't think so. This needs to be outside too. If maps dot contains and keys dot contains T of I. If I remove this, does this get key4? There's two D's, but keys at S of I must not equal mapped at T you already have that. There's two D's, but it's okay because keys at S of I is equal to T of I. Keys at S of I is equal to false. Keys at G false. Keys at GD keys at G. Okay, I'm done. I don't know. I think I'm confused. I thought this was not that bad, but I can't solve the last part. Easy. The codes are so hard for real. Reverse linked list. We can make a stack, then pop it back. Stack, 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 pop, 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 pop. Okay. Wow, iterator does not equal null pointer. Iterator, iterator, next. Stack dot how to push, iterator. Wow. Stack dot stack C++. Stack is not empty. I'm gonna do head is equal to stack dot pop. Stack dot pop. Pop back. Move top pop. Void pop. How do I get remove top? Stack dot top. Top. On the roots. Pop. Stack dot top. Stack dot top. Turn head. Yeah, we can reuse the iterator. iterator is equal to stack.top, and iterator is equal to iterator next. Stack.top would be like 5, 4, 3, 5 right now. Then we need to make 5's next into iterators next, iterator. Actually, wait, no, I can just do this next because then it'll end on the last one. So we can do iterators next is equal to stack.top. So the last one is already on there, then we can do pop. Then iterator. Alright. This one should be relatively easy. Iterator. Line 68. I don't have a line 68. My stack is not. List node utils. Why? Okay, I got my stack. Got head. Iterators next does not equal null pointer. My stack push is iterator. So 1. Iterator next one. 1. I pushed. Then head is equal to iterator at the end. 5. My stack is not empty. So while my stack is not empty and iterator is not equal null pointer, iterator doesn't equal null pointer equals 5. Iterator's next is equal to my stack.top. So right now the top of my stack is 4. Then I pop iterator is equal to iterator next. So 4. Oh, this doesn't work. Iterator's next head is equal to iterator 5. So iterator's next is equal to the node 4, which is fine. But it's still here, then iterator equals. No, that wait, actually that should work. Pop. I don't want to see my times anymore. It makes me sad. Iterator head is equal to iterator. Iterator's next is equal to my stack.top. My stack.pop. What is the value here? It should be my stack.top val. What? Why is there nothing? My stack.push. My stack.push. Stack C++. Bruh. This is push, insert element at the top of the stack, push. So it should be pushing iterator, the node. I don't need this. How do you make your stream quality so crisp? Dude, I just pressed OBS and press run. I don't think I did anything crazy. Also, I keep not being able to do questions. It's kind of an L. 4, 3, 2, 1. As long as what's going on, Cheese Fest? How's life? I keep getting errors. What problem? This one is 206. But I feel like I can do it, so don't worry. It's just I'm just sucking right now. And iterator. It's okay. I think this practice is good for me to figure out that I keep getting this error and I don't know why. That push. I think it's trying to do iterator. I iterated that next. Why the stack? So I can reverse it. Bruh. What would you use if you didn't use the stack? Well, true if it is. My stack dot empty. I don't understand. Is this stack? The stack should be empty. O of 1 memory isn't too bad. I think this is O of n. True. False, 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 true. There should be O of n because it's iterating through the entire thing. I don't know what's crashing my program. I'm confused. I'm pretty sure I did everything pretty correctly. Okay, it crashes at me returning head for some reason. I'm getting the O of 1. Oh, O of 1 memory. I see. Okay. Yeah, that wouldn't be too bad. My program's crashing at the very end though. So that's kind of an L. Wasn't crashing earlier. Heap use after free address. I'm just gonna make a new head. I don't know why. Okay, let me run through this. Push on the stack. So this is stack 1, 2, 3, 4. 4 is the last item on the stack. Not empty. Iterator is not null pointer. It's the last node because I stopped before the last node. Iterator is next. So this 5 is equal my stop.top, which is 4. My stack pop. Iterator is equal to iterator next, 4. Head is keeping track of iterator at the very beginning. Next is equal to stack the top, 3. Pop. Pop. Iterator is equal to. Pop here. Pop here. My stack is equal to 1. It's empty now. Iterator is equal to next. My stack is not empty. And iterator next is not equal to null pointer. This is now true, which makes this false. I don't even need the statement technically because it should be empty, which is when I want to stop anyways. This is where I want to stop. Now I want to return head. Heap free. I don't think I get rid of any memory, so it shouldn't be giving me heap free. Iterator is next does not equal null pointer. My stack.push iterator next. What? Okay, can I just get rid of this? Is that causing it? Okay, something in here is making it wrong, but I'm pretty sure it's correct. So let's see. Ah, I see where I did wrong. I didn't say this. It was circular. Okay, I have to remember, don't make a circle. Don't make a circle. How would someone do it? It's one. No stack temp. Previous. Oh, I see. So they just did it with a previous pointer. I think that makes sense. Always given an array of nums, return true if any. Sets. So you can do it just by iterating once through it instead of that. I think that makes sense. Yeah. So you get all of one memory instead of all of n. Yeah. Yeah, you're right. That would be better too, technically. Hash map. That second is equal to 0, so it has to equal 0. Else return. It always has to insert successfully. So if insert successfully, return false. Also return true. Sorry, I did this the exact wrong way. Yeah, I get every fail. Cool. How would you make this faster? That's interesting. Integer array return true. Probably instead of using a set, maybe you do I think you can do like the trailing pointers where one is faster than the other one. Yeah, because then you don't have to iterate through the entire thing. You only have to iterate through half of the solution. That's fine. Whoa, they're just giving me a bunch of stuff now. Return true if there are two distinct indices I and j in the array such that nums I is equal to nums day and abs I minus j is okay. Let's just do the same thing as last time. And the current index abs I. Yeah, if you need to do this one, you need to do rabbit and hare algorithm. But I think I want to do that later. Let's do this one. Count complete tree nodes. Huh? Don't you just DFS count nodes? I can have one between 1 and 2 end nodes at the last level each. Num nodes is So enter path. DFS with is this 222? Yes, it's 222. This will run in n. O of n. Left, right. Has to be done. If you look at this, you can't do DFS. DFS will run in one, two, log of n. Yeah, you're right. Okay, so I probably want to count the levels. Let me read. According to Wikipedia, every level except the last is filled in a complete binary tree, and all nodes in the last level are as far as left as possible. Then I'll just not DFS but explore left. I guess I don't really need a function for that. I can just do while iterator left is not equal no pointer. No, this was one. Huh? Oh, number of nodes in the tree. Oops. 1, 2, 3. Okay, so this is a possibility, but this is also a possibility. 1, 2, 3, 4, 5. Left. Right. One, two. I think you need to get the depth and then minus the nodes on the right. Jeez, Fest, how do you know how do you know all these questions? Do you like do them all or something? 1, 3, 6, left, right, left, right, left. Okay. Yeah. How long did it take you to do every single one of them? I think I'm gonna go right and then left and then I think I need to explore the left branch. It does say easy. But yeah, this one definitely feels hard. Right? 600? Oh, it's kind of crazy. I feel like you always want to check the rightmost node and continue down there. Because then that gives you the maximum. So as you go right, and then as you go down every single level, you can, this is 1, this is 2, this is 4, you add, just almost everyone's solution just does O of n. N is the number of nodes, right? So doesn't that... I don't know what that means. I don't know. I feel like this is a bit too hard right now. So maybe I come back to it later. Almost everyone left. I want to think a bit more harder on this. I feel like anything with a tree that includes calculating depth is pretty hard. Can I implement stack as Q though? Yeah, you could just cheat fast line. Yeah, but then it doesn't feel real if I cheat. Maybe I'll do that. Huh? Oh, it actually wants me to implement a stat using 2 Qs? What? This is such a weird question. What's the point of this? The Q may not be supported natively. What is this question? Alright, sure. Q. What does it want me to do? Just integers. I need to look at Q. C++, push. I feel like yeah, of course, I think so. I feel like this question isn't really that helpful because I don't know why you would need to do this ever. Alright. I'll go to 2001. 2001. My plan is to solve all of them eventually. I'm just gonna keep working on it. Problems? 2001. Destinate to maximum bombs. Okay. You're given a list of bombs, range of bombs, define the area. Bombs are represented by 0 index 2D integer array bombs, where bombs of x is equal to xi, yi, ri. Xi denote y and x, and r is radius. Wow, that's so interesting. It's 2. So this is a 2D array. because this is the bomb area. Boom. So I think I want to write function bool intersects. Because we want a function to see how many bombs intersect with one bomb. Actually, how many bombs intersect with one bomb if it's detonated. So for example, this one intersects with 2, so we want the number 2 to come out. This one intersects with however many, right? And then we can recall this function. So like if this has 2, this has 3, for example, then this will also blow up 2, which might blow up 0. Sorry, it's 3. What's 4? 4. Bomb 2 detonates bomb 3. Bomb 3 detonates bomb 0, because bomb 0 detonates bombs 1 and 2. Bomb 3 detonates. Have a graph problem. Let's see. I didn't really think about that at all, to be honest. So 0 points to 1 and 0 points to 2. Paint online. Is there paint online? We got 0 points to 1 and it points to 2 based off of the fact that it intersects. Then we can say that 2 points to 1 and 3. You're right, this is more helpful. Thanks. Then 3 points to 1, 2, and 4. So what's the best path? Well, if we point to 0, it can go to 1 and 2. So this 1 and 2. And this goes into 3, and this goes into 4. So 1, 2, 3, 4, 5. That's the answer. So we at each of the nodes we can run some algorithm to pathfind, not pathfind, to find the lowest score. I guess this means kind of pathfinding. Right? But I need to generate. I mean, I guess you can generate a graph first and then do DFS on the graph to find all the points, or BFS. I don't think it matters. Okay, I think that's what I'll do. And then we want to find the maximum path. Maximum path? Not even maximum nodes we can visit. I don't think I've ever made a graph in C++. Adjacency matrix. Construct graph with n vertices. Add an edge. Set edge for undirected path. Adjacency matrix. Number of matrices. I don't want an adjacency matrix though. I don't think C++ has a this I is all the numbers that I goes to, because you can represent your undirected graph as adjacency matrix. Okay, I think that makes sense. Okay, so I need to make the data structure though that stores this. Okay. Okay, sounds good. Bombs will further detonate the bomb cell behind the ridge. I think I still... First I need a dash structure so I can store if it's together. So I can either make it, yeah, adjacency matrix. This, I guess it would be an adjacency matrix because, but this is intersecting with this, but this doesn't intersect with this one. 1, 1, 5, 10, 10, 5. All these intersect. Okay, I'm gonna write down my steps. First, make a graph data structure using adjacency matrix and 2D array. And then we can form graph by intersection of bombs. If intersection, form edge. If intersection, form edge. Count max num nodes reached at each node. Return highest number. Adjacency list. I see what you're trying to say. So instead of having a list, is all the numbers. So instead of having a matrix, you can have a list that will store the edges. Sorry, my brain needs thinking power. Give me a sec. Adjacency matrix is good when you have equal weights between every single edge. In this case we do, but we actually don't really care if what the value of the node is. We only care about where it goes. So this adjacency list, you can use adjacency list to represent a finite graph. So in this case, we don't need an adjacency matrix. We can just use a list, which is just each array goes into a linked list. Okay. Okay. So for this, we would have 0 goes to 1, 2. It doesn't have to be a linked list. I think we can just do a 2D array where 0 is the first index. How many nodes can it reach? So this is node 1, this is node 2. In this case, we can... Okay, I understand what you're trying to say. That makes sense now. 3. I learned this like 2 years ago. It's just I don't think I've ever used it until right now. So the memories of 2 years ago is coming back. Thank you for reminding me. 1, 3, 3, it goes to 1, 2, 4. Yeah, so I was making a graph, and when I made graphs in second year, I was using adjacency matrices. So then you can explore every single node for the maximum amount. So if it's 1, 2, then you go into 1 and 2. Here you go 1. I already visited that one, 3 you already visited that. Oh, you haven't visited. So go 1. I already visited 1, 2, 4. Why are you silly? Had no need to add null, by the way, but sure. Yeah, this doesn't really point to anything. But if you... it's just the way that's represented in... Oh, you retracted that. I think the way it's represented in C++, 1... Well, actually, 1 takes up the first spot of my 2D array, so I need nothing there, so that it takes the index. Yeah, but I think you realize. Okay, so I don't... The graph dash structure is literally just a 2D array. I don't think I've used this much brain power in so long, so thank you for this. This is amazing. Okay, 2D array of vectors. Okay, where the first 1, 2. I think we need to go the number of bombs. So this, the number of bombs 0, 1, 2, 0, 1, 2, 3, 5 bombs will give us how big the adjacency list is and tell us how to make it. So we can repeat by this. Now we need to repeat that by that number, but we need to make sure that everything here is intersected. So the bomb at 1, 2 with radius 3, 0, 1, I guess it's the 0, right? This is a 0 bomb. We need to make the adjacency list based off of what's intersected with that. So graph dot insert that push back because it's a vector. Then I can put the list of bombs that's intersected with this one. Okay, so for that I need to go into every single one of the bombs and see which one is in the radius of this. So now I need my intersected, but I'm going to return a vector int for intersection. Okay, I feel like I know what I'm doing now. Before I kind of felt like I did not know what I was doing. So this is so great. This is pretty great. And then we're going to take in the 2D array of bombs. So we're going to do for in I equals 0, I less than bombs dot size I plus plus. So we want to do every bomb except I probably want to the one that we ignore. So we want to ignore I because that's the one we're at. So we're always going to ignore the one that we're at. If I is equal to j, then we're not doing anything. So I needs to not equal j. We also probably want to temp intersection. I'm so glad I can use vector. I remember I would just have to manage all the memory. And you can't use vector, so you have to make your own data structures and manage your own memory. So this is a lot. This is great. Temp intersection. We want to add only if it's in the way, so we can go through every single one. So we're at 0, right? So at j, we need to determine if it's in the radius. So it's I plus j. I also need to return the cur bomb, I think. That would be helpful. Cur bomb. So my current bomb is this one. So if I were to get the radius, the radius I need to, what is it, pi r squared? Wait, what? I need to get the circumference, wait, okay, sorry, let me map this. This 1, 4. So coordinates 4, 2, 1, 5, 1, -1, and then -2, 2. This is like the edges of the circle, but then it makes a corner. So how do I say it's within this radius if I draw a circle on the Cartesian plane? Well, to get any no need to radius and distance between 2 points formula. Yes. Okay, I wanna figure out myself. But what you're saying makes sense. Yeah, so like this is like your radius of the circle, right? But anything in between, for example, 0 to 1, it isn't if any other circle above the area covers the center. Yeah, I know that. So like it's only like if 0 and 1 and 0, 2, so like only these centers, right? So all of this overlaps because the radius of 0 reaches these, right? But all we really care about is yeah, you're right, the distance between 2 points. So if the distance between the 2 points is less than the radius, then that would be, so the area doesn't really help, but the Euclidean distance would help. Okay. So the coordinates are 1, 2. All good. I think your hints for sure help, because then I would probably have to think about for like 5 minutes, but maybe the satisfaction of like figuring out yourself is good. But you're right, you do need to do a distance because it's within the circle. Thank you for that. Anyways, to get the points, I can just do the distance formula. So this is my y and this is my radius, so I can do Kerr bombs at 0 less than Kerr distance plus Kerr bombs at I at 0. That's my x. Plus my y. And then all of that square rooted. Wait, x square root, this is squared, pow. This, I got hell, good luck. Alright, thank you. I will solve this question by some time. You gave me a hard one. Why? Thanks for coming though, I appreciate it. I won. Distance, and then we can square root it by powing 0.5. Okay, let me make sure I got that right. I think that's it. Minus. Okay, Kerr bombs distance. Kerr bombs minus 2. All of that's 0.5. So if that distance is less than or equal to the radius, Kerr bombs at 2. True, and it's not its own bomb. Then we can do temp intersection dot push back the current index I. Then this can be intersection of bombs, graph at I, so bombs at I, and I. So yeah, I think that should give me the adjacency matrix. Form adjacency list, not matrix. So after you do that, we have to go through the entire graph. Form edge, yep, done, yay. I'm 2/3 of the way there. Count max num nodes reached at iterate. Iteration. So here we have 0 goes to 1 and 2, 1 goes to null 2. So I think we can have a visited set of ints visited. So this will be stores index of visited nodes. So if it's already visited, we're not going to visit again. If visit dot contains I, then no visit. But I think to do this, we can go through this 1, 2. So, but if they have it, then we have to reiterate through the graph. Okay, give me a second. I need to go washroom. I'll be right back. Washroom BRB. I changed my mind. I like coding. Alright, I'm back. So, yeah, I think I'm just gonna write another function to visit. And then it's going to, yeah, visit all the nodes. So I'm gonna give it the initial node. So 0, for example. And then I'm just gonna do a for loop. So 0 is going to visit 1 and 2. So then this is going to call a function. So if I call 1, it's going to call a function on 1 and do a for loop on all of the graphs on 1. It's going to go 2, go 2. Unless we already visited that one, then we're not going to do that. Then it's going to do that for 1, 2, for 2, and 3. So I need I just need a vector of ints for actually I just need the int max visited, max nodes visited, which equals 0. So and for this one it would be all of them. It would be 5. Sorry, this does need to be a vector. So for every single starting node, there's a different number of max nodes visited. I want to keep... Actually, I guess I can just keep always the max. Okay. Yeah. Then we're going to call... void determine max determine nodes visited. So we need to give this the graph at I. So this needs to take in a vector int of 2 visit nodes. We should also give it also needs to keep track of visits, so it doesn't visit the same node twice. So for each one of these nodes, so 1 for example, we're gonna, as long as if visit does not contain 2 visit nodes at I, so if visit does not contain 1, we're also going to visit.insert I here after, but we're going to need to go into the node 1 graph vector. Oh, this question's good. Why don't I just do... this, and then I can do this. So then it's gonna go through I J J. Give them graph here. So that's 1. Okay. As long as this. Okay, now I'm gonna take this. I J, then we'll insert IJ. Okay. We're gonna clear this up. Clear. Okay. Determine visit nodes. So this is going to do for loop to for loop graph at graph of I of j. So graph I of j graph. So for to is size, and then we don't even need this. All we need to do is count the size of this. Here's 0. Max nodes visit plus plus. So this should be 2. 1, 2. But then there's more because this goes into 2. And 2 goes into 1 and 3. So determine nodes visited. We'll give you 1 and 2. I feel like I need some recursion here, or else this isn't going to work. Okay, all this is going to do is look at this and loop through all of it and then run itself onto it. I think that makes sense. To visit nodes, what size? Okay, let's run through the first example. So this is 0 contains 1 and 2. Visit does not contain graphs 1 and 2. Determine nodes visit for graph at ij. So it's 0, 1. So here 1. So it's going to run this function. Then it's going to run, I have this one. So for this one, I want to run this function on it too. So determine nodes visit for visit nodes at I visited. But only if I think it's just the same thing as this. Do I really need this one? I don't think so. So I run on 0, 1, 2, and 3, then it just calls its own function. So 1 goes back, calls its own function, 2 goes back, calls its own function. I don't really need this other for loop then, to be honest. I just do determine nodes visit on graph at I. Actually, I should just do I. You know what? Okay, can I just run this through? So let me break this out. So if visit.contains graph at ij okay, let's just, I want to make it clear. So this, I'm gonna give it graph at I, which is this graph at I. So I give you this and visit. So now you take this graph at I, and then you're going to, I also think I need to give you the actual graph, else this isn't gonna work. So graph at I, then visit nodes, you're gonna go through all of them, all 2. And if visit does not contain, it does not contain 1 yet. Determine nodes visit, it's gonna call itself onto 1. So this function repeats. Then for in I equals 0, I less than 5. So this is 0. Because there's nothing in it, so that exits. So then that breaks out. I visited 1, so insert 1. We're also going to add the max nodes visited. Plus. All right, cool. So I visited 1 now. Now I visit 2, because I call, this goes up back here. Visit 2. Nope, visit hasn't been. 2 hasn't been visited. So I'm going to determine nodes on 2. Okay, 2 visit nodes at I. 2. I need to do not 2 visit nodes at I, but I need to do graph at 2. So graph at 2 visit at I. 2 visit at I is, yeah, so that's a 1D, right? So that goes into 2. So 2 has 1 in it. Oh, it's already visited. Sorry. But how about 3? Well, I call 3 into this. Okay, so I call 3. So it goes up to here. Does it contain 1 or, oh, sorry, visited 1 already. Skip. Here, haven't visited 2 yet. Or I should put this up here. I have visited 2 already. Because I already have a recursion into it. So I already visited 2, so that doesn't count. And then I do 4. 4 is just to null too. So 4, this happens, I visit 4, I add to 1. Okay, 1. Okay, now I go back up. So 3, I'm done visiting all the nodes at 3. Graph at I. So 3, maximums plus plus, okay. Then this breaks out. And then this comes here. Void size plus plus. So that will be 2 plus plus for 2. And then that'll give me my next visit, actually. So that's if I start at 0. Boom. So that's me starting at 0. Now I have to start at 1. So I clear visited, and then I start at 1. Okay, cool. So then, but I can do this. If temp max, no, this is temp max. It's temp max nodes visited. Then I can do if temp max nodes is greater than max nodes is equal to temp max nodes. Then I can also do temp max nodes is equal to 0. And then I can return max nodes again. Boom. That's my solution. Run. I'm gonna get errors, Kerbomb. Man, if only it just worked first try. Oh man. Very expected. Okay. There you go. Create adjacency. 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 Just. Determine nodes visited. Oh, okay, yeah, I'll kind of use a pass on the graph. Temp max nodes. Temp max. Undeclared identified temp max nodes. Temp max nodes visited. Deadly signal, Stack Overflow. Oh no. Okay, let's see how well this debugger runs. Oh, I don't think it runs at all. Okay, can I do for in I equals 0, I less than size, and then plus plus, I can do for int j equals 0, j less than bombs dot at I dot size I plus plus, and then scc out edge bomb I CC out bombs at J. CC out cd line. See if I made this adjacency list correctly. Yep, I didn't see that. So the one that I'm expecting is 0, 1, 2. Oh, it's just not created correctly. Oh, this should be graph, that size. That would make a huge difference. All right, let's see. Huh? What? Did I do something wrong? I don't think so. JSON 0. Now I want to print 0. I want to print 1 and 2. Two, 1, 3. What did that error? Heap buffer overflow. There we go. That's okay. Okay, so 0 goes to 1, 2, 1 goes to nothing, 2 goes to 1, 3, 1, 2, 4, and bump 4 does not go to 2, 3. Bump 4. Bump 4 is 5, 6, 4, 1, 2, 3, 4. Oh, it is 2, 3, but it's not 1. Okay, that's fine. Alright, so my adjacency test works. Adjacency test. Okay. Set visited, intersection time. So let's run this by again. So we have determine nodes visit. Determine nodes visit on this. So this is at node 0. So I give it 1 and 2. Then for determine nodes visit, I do graph the 2 visit nodes. Okay, size, so that's 2. Visit does not contain visit nodes. It does not. Visit.insert I. So now we have 1 inserted into visited. Then we determine nodes visit graph at 2 visit nodes at I. So 2 visit nodes at I is 0, so it's 1. Oh, this does need to be after. Because it's I said that we already visited, but we didn't yet, so that has to be after. Okay, anyways, so this says I need to visit 1. So 1, this is 2 visit.size, which is 0, so this should not run at all even. Then it just keeps. Then we go visit 2, because this loops again. Sorry, this inserts, we visit 1 node. Okay, loops. So it contains 2. Okay, 1, 2, 1, 3, 1, 2, 1, 3, 1, 2, 1, 3, 1, 2, 1, 3. What? It's because it's never able to insert the visited. So if I do it first, then I have to add that at least. So 0. I think I have to do it at the end here. Doesn't make sense if I do it. I should do it at the beginning. Visit, insert I. So I visit 0. Now I go into 1. I visit 1. Node known is 0. I, so 0, insert I, visited, insert I. But once I get in here, we're adding node known. So 0, we add 0. Okay, that should work now. What? How? Visit dot insert 0. Visit does not contains to visit at I, so that's 1. Determine graph to visit I. One, 2. Yeah, but I already visited 1, so I have to go with 3. 3 gives me 2, 3, 2, 3, 2. This makes sense. I already visited 2. Here it says it did, so I visit 1, okay. I visit 2. Visit should insert 2 in. 2 should be inserted in, because then it's just the 3, which just makes sense because 1 is already visited, 3 is not visited though. And 3 has 1, 2, and 4. So here I should see, I see 2. 3. But visit should have inserted that already. No, that's not right. It should be 0. Should be 0. Then there should be 1. Why is it 1 repeated? No, that's not right. Oh, I did this wrong. That's why. Okay. Perfect. Okay. We did it. Whew, okay. It doesn't max out now. So now we can see why it's wrong. So we did the first one. What's the adjacency say? Zero has nothing. Okay, yeah, that's fine. Bottom one has 0. Yep. So then we can go here. Graph determines node visit. Graph at I, which is nothing. Visit and 0. So we can say visit. Oh no, but there's nothing in it. And this is 0. Visit. One. This one has 1. This one has 16. Okay, I do want to add only when it's already been visited, but for this one it's broken because it's saying I already visited 0, but I didn't visit 0 yet instantly. So I think I need to do this at the end. Contains, so this is, you know, me by itself is 1. Then it goes back to here. 1 is the greatest, so we store 1, that's fine. Clear visited. We start at 1. That has to be I, that can't be 1. And then this can still be at the beginning, because yeah, I did visit 1. Visit 0. Temp 1. I think this should always start off as 1, to be honest, because it's always visiting itself. Okay, what is wrong with this one? Why is it 9? Adjacency bomb. Okay, so visit 1 first, then visit 2, then visit 1 and 3, 1 and 4, 1 and 3, 1 and 4, 1 and 2. Huh? Why is it visiting 1 so much? 1 should be already inserted. So 1's 0, it visits 1, and then 2. And 2 visits, but it's already inserted. We insert 0, then we visit 1. Okay. Then we insert 1. Perfect. Then we visit 2. We insert 2. How do we visit 1 after we insert 2? That doesn't make any sense. 0, 1, 2. How do we visit 1? Oh. Contain. Visited dot contains does not contain. So here, you know, we insert 2. Does visit dot contains 1? Yes, it does. So it's false. Don't do that. Why does it still insert 1? What? Is this my op? Is this guy changing every single time? Is this just changing locally? Okay, there we go. Bruh. Okay, now it makes sense. It needs to be passed by reference because I don't know. Oh no, please work. Let's go. It's so slow though. Okay, we did it. That's what matters. Why is it so slow? I don't know. What if I swim again? Let's see. $500 milliseconds. Okay, 2101. Alright, you are welcome. Cheese Fest. I did it. Is it slow? Yes. Do I know why? I mean, kind of. It's probably because I keep visiting the nodes even though I already visited them. I should probably just be like... If I... yeah. I think you can make it fast. Anyways. I'm quite happy with this. Okay, I'm gonna stop for now. Thanks. Going to talk to friends.